Now this example is a good one, I think, because we haven't yet learnt any methods of integrating this function, y equals 1 over x. And the reason we haven't learnt a method for it yet is because it can't follow that usual rule. When we rewrite it as y equals x to the power of minus 1, we can't do our usual trick on that, because when we add 1 to the power, we get x to the power of 0, and then dividing by the new power, we'd have 0 on the bottom of a fraction. So clearly our normal methods for integration won't work. So we can use the trapezoidal rule to come up with an estimate for the area under the curve. Now here, I'm trying to come up with an estimate for this area underneath the curve between the bounds x equals 1 and x equals 4. So I'm going to start by using one trapezium, which won't be a great estimate. It's going to slightly overestimate the area, isn't it? And then I'm going to divide it up into 3 trapeziums and then into 6 so that we can have a look at the process each time. This one will obviously be the best estimate. Now the first step, draw up a little table of values of your key points, because if you want to find the area of a trapezium, you need to know how wide it is. That's h, the height. Remember our trapezium is on the side. And you need to know a and b, which is the parallel sides. So we're going to need to know this length and this length, and we'll find that by plugging in when x equals 1, what is y? Now you can see that my scale is quite different on the y-axis than it is on the x-axis. That's okay. For the purposes of this exercise, my sketch is just showing me where everything is and what my numbers are. So when x equals 4, I can see that y will be a quarter. So this point over here is a quarter. Now you don't need to label that on a diagram, but we're just thinking through here that what this means is that this length is a quarter of a unit, and this length over here is 1, and that's our a and b. Next thing, I've said, well, all right, I've got the integral from 1 up to 4 of 1 over x dx. I'm going to estimate it, so I can't put an equal sign because my calculation for the area of the trapezium is not going to be exactly equal to the integral. It's just going to be an estimate. Now there's 2 symbols you can do for approximately equal to. You can do an equal sign with a dot on either side. I've done nice big coloured in dots here so that you can see them. The reason I'm not such a fan of this notation is that if you just put a dot with your pen, an examiner might not see that and it might be mistaken for an equal sign. So I prefer the other symbol for is approximately equal to, which is an equal sign that's a bit wobbly. And that's a lot easier to spot. It's not exactly equal, but it's an estimate. Looks like a set of waves. It's kind of cool. Okay, so it's approximately equal to, now think through what's the area of a trapezium. Height over 2. So what's the height here? Remember it's on its side. So the height of the trapezium is 3 units. So 3 over 2. And then I need to add my A and my B, which is my 2 outer sides. So I have 1 plus a quarter. And then you can just tidy that answer up. Now that you've said it's roughly equal to this, we can then say that this part is equal to, because this will be exactly equal to something, won't it? We've got 5 quarters times 3 halves. So we've got, what's that, 15 over 8. And that's the approximate value of that integral. Now I haven't been asked for area here, I'm just finding the approximate value of the integral. So I can leave it there without any units. All right, here we're dividing it up into 3 trapeziums, so there's a little bit more work to do. We still want to start the same way though. We need to know what are the lengths of our trapeziums. So we're going to have, say, an A and a B here, but then let's call this B and C, C and D, because we've got 3 different trapeziums. So start with your table of values, x and y. We're going to need to know 1, 2, 3, and 4. We already know 2 of them. And obviously, if we sub in 2 for x, we've got a half and we've got a third. Okay, so next we can say, all right, our integral of 1 over x dx is approximately equal to... Now, I want to put a line of working here that's going the slow way, and then we'll have a look at how we can take a few shortcuts and remember how to get the shortcuts right. So let's just look at this trapezium first. What's its height? 1. So our formula, remember our formula, and jotting this down on the side to remind you is not a bad idea. Our formula says get the height of the trapezium over 2. So that's going to be 1 over 2 for this first trapezium. And then I have to add, in brackets, this length to this length. So that'll be 1 plus a half. So I've got 1 plus a half. All right, now let's do the next trapezium. How wide is it? That's the height. Same, it's half, isn't it? So we need to add it on, because we're going to add up all the trapeziums. We've got a half times, now we need to do this length plus this length. So that'll be half plus a third. And then for the final trapezium, we have the same height, and it's A and B, which we're saying AB, this is C plus D. We've got this length plus this length, so that's the third plus a quarter. Now, when you use the trapezoidal rule, here's the thing. It's smart, and something we pretty much always do. We break the trapeziums up so that they're equal widths. Here I've got one, here I've got three. I've made them the same width as each other. It doesn't make sense to have one skinny little trapezium and then one fat one. We make them all the same size. So if I'm dividing an interval into three trapeziums, I'm going to make them all the same. Here I've got 6 of them, and they're all half a unit wide. So what you're going to get in your working, if you do it the slow way and add up the trapeziums one at a time, is these halves, which here is because the height of our trapezium, the width, was actually 1. We've got half of this plus half of that plus half of that. Now if you've got half of a whole bunch of things, you can actually just write them all together, can't you? You can say this is the same thing as a half of this plus this, plus this plus this, plus this plus this. And we can do half of all of them together. So we've got 1 plus a half, plus a half, plus a third, plus a third, plus a quarter. Now, can you see a pattern going on here? This length only had to be added once, and so did this one, because they were on the outside edges, weren't they? Whereas each of these other lengths had to be added twice. This one because it was the bottom of this trapezium and the top of the next one, and this one was the bottom of one trapezium and the top of the next one. So we can get to see a pattern here and take a bit of a shortcut and say, all we really need to do is find the height of one of the trapeziums, 1, put it over 2, because that's what we always do when we're finding trapezium area. And then in our brackets, what we want to do is we want to do one of these lengths and one of those, and 2 of all the others. So once you know this shortcut, you could come straight down to here and say it's roughly equal to half of. Now I've got 1, because I've got one of these, and I've got one of those, and then I've got 2 of everything else added up. So I'd have 2 lots of a half, which in my head I can say that's 1, and 2 lots of a third, which in my head I can say is 2/3. And this makes your working a lot quicker and easier, but it's really important you understand what it is you're doing and why you're grabbing 2 of these lengths, but only 1 of those. So we'll have 35/24. Now you could do that whole thing on your calculator to make sure you get it right. I just don't have mine on me. Now we're not putting units square, we're literally just coming up with an estimate for the integral. And this will be a lot closer than that one.